Machine Pencil Cartography. This channel's goals involve teaching my audience about navigational topics. Today, I would like to educate you so that you can learn about mechanisms of arrest. The basic premise for mechanisms of arrest are that in the operation of a navigational vehicle, we may observe the risks associated with operating a vehicle without brakes. This may result in the creation of incorrigible vehicles, where the operation of the vehicle poses significant hazards of collision with your fellow navigators. In truth, operating a vehicle without brakes poses just as many risks to your own vehicle as it poses to other vehicles. And obviously, installing brakes onto your vehicle is the responsible thing to do. In order to comprehend the navigational context, we will remember that when examining the methods of vehicle propulsion, accelerating, steering, etc., we are discussing aspects of rheology, which discusses mechanics of how much force or power it will take to move any carrier. I may remind you that when deliberately accelerating carriers, it will take energy to accelerate the carriers, and this is usually called an assault, or sometimes rifling behaviors if you're one of the cool kids. Rest assured, these nomenclatures originated in the scientific study of rheology. So far, we have discussed how to make things move relative to the Earth's surface. When discussing how well your carrier will yield in emergency braking scenarios, we are much more interested in making the carrier remain stationary in comparison to the Earth's surface. In rheology, mechanics that achieve this are known as mechanisms of arrest. It should be considered that navigational carriers don't stop on a dime, and every vehicle has something known as a braking distance. This is defined by the distance that it will take to bring the carrier to a complete stop. The braking distances of vehicles will depend on the weight and speed of the carrier, as these comprise the vehicle's momentum. Your brakes actually put out a limited power level, and even though the power demands of your brakes are less than the power demands of your engine, the power demands of your brakes will often be a non-trivial portion of your engine's total power output. As a result, these power levels are often measured either in kilowatts or horsepower, meaning that they are absolutely comparable to the power of the engine. Therefore, this amount of power should demand just as much responsibility as your engine. The most emblematic representation for mechanisms of arrest in navigation would have to be the ship's anchor, because this mechanism is external and highly visible. In review, your brakes are a crucially important article of safety equipment, and maintaining your brakes can be vital to navigational outcomes. In rheological terminology, these are known as rheological mechanisms of arrest. An interesting fact is that these can also be applied to help navigators keep geostationary courses. These courses are known as navigational stands. Thanks guys, this has been Machine Pencil Cartography, signing out.